This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
Hey everyone, welcome to another Ruby Rogues episode. I'm David Kimura, and today on our panel we have Catherine Meyers.
Hello, hello.
And David Richards.
Hello.
And we have a special guest, Dan Manges.
Hey, thanks for having me.
Yeah, so Dan, tell us a little about yourself, who you work for, and what you've been up to.
I'm the CTO of Root. Root is a startup in Columbus, Ohio. We're a car insurance carrier, just like Geico, Progressive, State Farm, Allstate, all of them. And we started the company a few years ago because we believe the price that people pay for car insurance should be based primarily on their actual driving behavior. Whereas traditionally, insurance rates have been set on things like age, gender, and general demographics. But of course, two people of the same age and gender could drive very differently from each other. One person could be safe, responsible. Maybe they don't even drive all that often. Somebody else might be aggressive and reckless and drive a ton. And those two people shouldn't be paying anywhere close to the same price for their car insurance.
Yeah, absolutely. Which Root was around when I was growing up, would have saved. Actually, we would have been paying a lot more money. So never mind.
A lot of people think that. A lot of people think that, oh no, if my car insurance company actually, if they had some insight into how I drive, I'd be paying a lot more for my insurance. But that's actually not really the case, or at least I find a lot of people are a much better driver than they think they might be. In general, based on the data that we have, about 30% of people should probably be paying more for insurance than they're paying today. But then, of course, conversely, 70% of people should be paying less than they're paying today.
Well, that's really interesting. But a bit about the actual Root application. So you guys are tracking the driving habits of users in a way to where you're able to determine what their rate should be. And you've built your entire application stack on Ruby on Rails. Can you tell us a bit about its architecture and some of the things that you guys have done with that? Because from your blog article on the Modular Monolith Rails architecture, it was a fantastic read. And I just want the viewers or the listeners to hear a little bit about that architecture.
Yeah, I'd love to chat about it. We've built a backend platform on Rails, which facilitates most of our business logic. And it's really where I'd say like the primary set of functionality that we have powering the business really lives. We've built a rating engine to determine what somebody's price for insurance should be, a policy management system to handle that entire policy administration of issuing policies, mailing out insurance cards, generating policy documents. Not surprisingly, I'm sure to many people that have worked in financial services companies, we've done integrations with a ton of third parties. We have to report policy data. We have to run a variety of reports because even though we do price insurance based on actual driving behavior, we still look at things like motor vehicle records. We run reports, and we have numerous and supporting that part of our insurance experience. So we built a backend platform in Rails that contains most of that business logic. Primarily, it's just an API for our mobile application. Because we gather data on driving behavior using mobile apps on both iOS and Android, and we require people that want to get insurance from us to install that mobile application, we decided to make mobile the primary user interface to Root. So right now you can't go and get a quote on our website. The only way to get a quote from us is with our mobile app. And as I mentioned, our Rails backend is primarily just an API for that mobile application.
Cool. And so when you guys started off, you had initially had just the standard monolith Rails application where all the controllers, business logic, which is all under one application. Is that right?
Yeah, when we started off, basically one of our engines typed Rails new, and we got to work. we really had a pretty massive undertaking in trying to build the entirety of the software that we needed to start a car insurance carrier from scratch. And we thought the best thing was going to be making serious headway into that. And we just started off with one backend application, probably like many developers have started building. We talked about microservices and things like that, but we really felt, especially initially, like we'd be able to make the most progress as fast as possible by going with a monolith first.
Mm-hmm. And since then, you guys have strayed away from the traditional monolith into something else. Can you kind of explain the new direction or the current direction you guys are taking it?
We did start off just building a monolith, but I think several of our engineers had past experiences of knowing that that could be difficult to scale. And obviously lots of companies end up going with microservices. I think as a reaction to that, as a reaction to feeling the pain points from a code base growing too large, of continuously adding functionality to it, test suites taking too long, it becoming very unwieldy to work with. And while we recognized that that was an option to start extracting things out into services, we didn't think that was the step that we should take to avoid having our monolith become too unwieldy to work with. What we decided that we wanted to do is try to identify good architectural boundaries in our code base so that if we did want to extract functionality out into services, we already had those interactions well defined. Mm-hmm. We basically started building an architecture that we call a modular monolith, where we take our entire Rails application and define it, the entirety of it, as engines and gems. Really the main distinction there being that gems don't use the database at all. They use active support, but they don't use active record. Whereas engines do have persistence. They use active record. They put data in the database. Engines also can have controllers, which is like where we expose our API endpoints. And this has been tremendously helpful in helping us maintain the velocity of delivery that we had when we were first getting started with a small Rails application, even as our backend platform has grown to be substantially larger than it was when we first got started.
Can you talk as to why you decided not to go the microservices route and keep it in a modular monolith instead? And maybe give, for some of our listeners who haven't dealt with bigger applications, a high-level overview of why someone would even think about breaking up their monolith and going into microservices.
The main reason that we didn't want to go with microservices is because they introduce some trade-offs in terms of your efficiency of making changes. And I've heard this experience from numerous people that have worked on platforms built on top of a microservices architecture where somebody has a feature that they want to implement. It's fairly straightforward, a pretty simple change. And due to the overall architecture of the system, they need to open up 5 pull requests across 5 different services. They need to make sure that the backend service is deployed first, and then merge in the pull request that changes the client that integrates with that service or some other service to use the client that integrates with the downstream service and update that. And I think we just recognized that there was a big risk of introducing a lot of inefficiencies into our process by taking our backend platform and making it too fragmented.
I've been there. Yes.
Yeah, the whole deployment of that scheme can, really start to become more difficult, even with the CI/CD, because if things aren't timed out perfectly, then you have new code in one area trying to interact with old code in another area, and it could give some quirky interactions or app crashes.
And I think those deployment order dependencies are really impactful in terms of a team's ability to actually implement new features, especially if you're introducing the constraint that interactions between every single one of your services need to maintain backwards compatibility. It becomes a lot harder to make changes. Just like it's harder to migrate your database schema without actually taking your system down for maintenance, and as if you just have a maintenance window when you can do that. Being able to change your database schema such that code that's running before that schema change happens is still operating, and such a code that's going to run after that change works correctly, typically involves a multi-step deployment process. You need to add a new column while you're still using the old column, populate the new column, and then go back, roll out the code change to fully use the new column, and then drop the old one. And I think you apply that to every single change you're making, and all of a sudden you have just more inefficiency in your engineering process in general, or you don't always need it. And I think you can do what we have with a modular monolith, and it's much more streamlined. Like if we want to rename a field, we have our code separated into architectural components that are modular, that can stand alone, that can be reasoned about in isolation. At the same time, if we want to make a change to the communication protocol between two of those components, as of right now, we can change two of those in one pull request. And because we deploy our application still as one process, it doesn't require this incremental step-by-step change to maintain backwards compatibility as that change is rolling out. We just roll it out all at once.
Cool. And so with the engines, those are basically typically Ruby gems that have a encapsulated Rails application within there. So do you guys just have one large schema, or are you deploying to separate databases per Rails engine?
We don't have separate databases per Rails engine. And that's something where we can also, I think, maintain some productivity, like relative to the experience of just building a monolith. And because we can do things like have modular components of our application that do have data associated with those components, but by putting it in one database, we can still join across those tables if we need to. Whereas, of course, as soon as you start splitting out into multiple databases, you can no longer do that, which means you have to shift some of that logic of joining data together into your application layer instead of your database. We do have two different databases. So one of our engines, it's our what we call telematics. Telematics refers to remote data collection on how people are driving. Our telematics data is in a separate database, and that's trips that our users are taking, some core location information, and then also all the data science operations that we perform on that. And that data, we wanted to maintain in a separate database primarily due to the size of it. I think we had some different scalability considerations there. And we did split that out into a separate data store, but otherwise all of our engines use the same database. The main thing to note, though, there really is that because engines define models for their database, it means that even though those tables are on the same database, if we're running tests for one of our engines, it can really only use the tables that that engine owns, that engine has the active record models defined to interact with. I suppose an engineer could do something awkward to try to walk across that boundary, but for the most part, we haven't had issues with that. So for example, we could have like an authentication engine that has users and some API credentials. And when you're running the test suite for that engine, those are the only data models that can be used in that code. And this is hugely beneficial in helping us just maintain really clean boundaries between the engines.
Cool. And then in the main application that's encapsulating all these engines, do you guys have like separate integration tests there to test like the cross-engine compatibility to make sure things aren't breaking?
Testing is an interesting question. I would say right now we actually lean more towards having what a lot of engineers would call integration tests between the various components. So that's another, I think, nice thing about a monolith. Because you're basically importing your dependencies as libraries and not as external services, I think it greatly simplifies the integration logic between those things. So for example, one of the gems that we have is our rating engine. And our rating engine is responsible for calculating what somebody's price should be for insurance. We've implemented that completely statelessly. So we don't rely on the database at all. It's just a function that we send a ton of data into in terms of the data that we have available on somebody that wants a quote for insurance, and it returns a price. That alone is something that we realized primarily from building this architecture. When we actually first implemented our rating engine, we had a dependency on an active record model that defined the source data for insurance coverages, like the coverages that were available in the state that the person lives in. And we realized that because that data was reference data, we really didn't need to maintain that in our database. We could actually just put it in the application itself. And by making that change, we then made our rating engine completely stateless and not reliant upon the database at all, which I think was a nice architectural improvement, but it was kind of hard to realize that we even had that coupling to the database when it was all just inside of Rails. So we took our rating engine, we put it down into a gem. We then do have an engine that sits on top of that handles persistence for that. So when somebody gets a quote, we want to save that quote that we sent to the user in our database, of course. So we have a quoting engine that sits on top of the rating engine that will take the price output from it and persist that in the database. And for the most part, we just have integration tests there. Like as we're testing our quoting engine, we go ahead and we run through code that's in the rating engine down below. And I think it actually works out pretty well for us. And you actually don't have the latency that you would have with services. obviously the more services you introduce into your architecture, the more latency you have between those integration components, the slower your test suite gets, the more you're needing to use Docker Compose or something to maintain this big web of dependent services and set up integration tests against them and everything. And we really don't have any of those complexities because all of the individual modules of logic that we have in our backend component are really just imported as gems.
That's really cool. And so when you guys do a deployment, you say you deploy it as just one large monolith, but do you have separate servers that are just handling one particular endpoint for like the quoting engine or something like that? Because maybe those need more CPU instead of RAM. So you handle those a little bit differently while still having the entire application deployed on it. It's just hitting that one endpoint, which is hitting those one set of servers.
Yeah, we do. We have different performance characteristics, exactly as you just mentioned, from different parts of our application. And is maybe a coarser grained example, we have an engine for a set of API endpoints. And for the most part, it's just a very thin wrapper over our service layer. And most of our actual business logic is defined in service classes. The API engine sits on top of it, effectively not doing too much more than just wrapping those services, those service classes, in an HTTP interface. So clients can integrate with it over a JSON API. And that's one set of endpoints that we expose that gets deployed and run as their own processes. But then we also have an internal admin dashboard. And that is like a Rails app, typical Rails views, not a lot of functionality, mostly just displaying data for our customer service team and employees internally to be able to help out our customers and look at information in our system. That admin engine is its own standalone engine that's also really just kind of a thin wrapper over a lot of the domain services and the core domain data that exposes that admin interface internally. And we deploy that in a separate set of processes as well. As I'm sure you could imagine, it has its own authentication, it has its own security parameters, a few different runtime characteristics of getting that into production. But the nice thing is it's all in one code base. However, the API and the admin engine are completely independent from each other. They're defined separately. There aren't any dependencies between the two. And I think this even helps with some of the downstream dependencies that we have. Our admin engine has some libraries that pertain to web views and showing content in a web application. And we define those dependencies specifically as part of the admin engine and not other parts of the application. So as we're working on different parts of the app, we also kind of know which third-party dependencies we have that are and aren't in scope. Based on the engine containing those relationships.
Yeah, that's fascinating. I love it because I think I played around with doing something similar where I had a main application. This main application had device and the user model, but then all of the actual business logic for different areas of the application, I use as Rails engines as just a mountable path. And that was a nice way to kind of segregate it, but you still had a lot of the issues of, or the questions of, does everything get stored in one database? How do you do deployments? What's more the heavy calculation side of things? And I think that your blog article basically laid out and answered a lot of those questions just simply because it's some visibility that we don't see much in this community. We don't see people really supporting the monoliths or doing a modular monolith like you guys are. I think that's even fewer.
I certainly haven't talked to too many people that have architectures that look like this, but I highly recommend it based on our experience of doing it. Of course, your mileage may vary. I think that's always something you have to say in these situations, and maybe what works well for one set of business problems doesn't work well for another. Obviously, there's some limitations and constraints. Because it is one application, we lose some of the independence that you get from distinct services. For example, obviously, if you're using microservices, you can implement one service in one language and a different service in another one. But so far, that just hasn't been an issue for us. We're constrained to everything running in the same Ruby runtime, but that really hasn't been too problematic. And on the other hand, we've found really great architectural boundaries in our application. I actually think if we would have started off from microservices at the start, we would have gotten a lot of those wrong. And the awesome thing about having this in one code base is that it's easy for us to move those boundaries around a little bit as we realize that maybe we didn't quite get those API interactions between services right the first time. And I think that's really helpful. You can almost think of a modular monolith as having microservices in a mono repo. And I think that strategy works really well.
Mm-hmm.
One thing that really impresses me about this is that, I mean, it seems graceful what you built and it seems to work really well, but that you were able to work inside out. You were able to start with a solution and then based on results, based on how it worked for you, you continue to adjust and move and figure it out. I think sometimes I get myself in trouble, and I definitely hear this a lot from other people where they have this other ideal in their head of what it's supposed to look like. And so it's an outside in type of architecture where they're trying to meet somebody else's standard instead of using the code and the domain to teach how to build the system. That seems very graceful the way you guys built that.
Yeah, thank you. And I totally agree on the approach. It's pretty common to hear engineers on our engineering team at Root just asking if something that somebody proposes is solving a problem that we have. We have a lot of things that I think engineers would look at and maybe say it's not ideal or it's not going to work or scale correctly. And we just look at those problems and just ask, is it a problem? Is this something that we need to solve? And I think by doing that and staying really focused, it's helped us get to the point we're at today, and where now Root is growing exceptionally fast, but we've been able to keep up with that and just make adjustments as we grow. And if our business wouldn't have been as successful as it is today, if we would have struggled to find product market fit or run into any of those numerous problems that startups frequently encounter, the good thing is we wouldn't have over-engineered a system that was building the wrong product. But as we gain confidence that what we've built is the right thing, then I think we make further investments in improving the overall sophistication and maturity of the architecture and the platform.
And I think to be able to just underline that one more time, because I've been in enough arguments, or I've listened to enough arguments between developers where they come to it with their other ideas, and the wisdom to be able to say, yeah, but does this solve a problem for Root? Because there's a level of discomfort that we have to live with, right? Like until we can't solve all the problems, and we have to grow with the product. And so being able to hold that tension line, I just want to underline that, because a lot of really seasoned managers haven't been able to pull that off. To be able to hold that tension line of, yeah, there's things we wish we could improve and things, but is it serving our customers today? Can we grow from where we're at? And that's just not common. That's so. Dear listener, if you're if you're not hearing that, this is rare. This is important.
Yeah. And so you started out with a more typical Rails app, right? With an app folder and all that jazz. And then you refactored into, just having a gems folder and an engines folder. That sounds huge. How did you do that while building features and balancing everything?
The biggest thing that we really looked for were opportunities to extract portions of code that we felt like could stand in isolation, that we could reason about, that embodied a concept. And I find this to be really important. It's actually, I think it's somewhat easy in like a natural architecture, the way you would normally write code, to kind of end up with certain concepts littered throughout the code base. And interestingly, trying to build this architecture in this way almost applied this constraint in terms of how we would implement things, such that trying to arrange these dependencies in a way that made a lot of sense just forced us to write better code. I think one of the biggest things contributing towards that is the fact that we don't have any circular dependencies at all. And a very nice thing is we got that completely for free because Bundler won't allow it. In Bundler, if you try to have a dependency point to gem A point to gem B and gem B point to gem A, Bundler won't allow you to do that at all. So if somebody on our engineering team inadvertently goes to introduce one of those circular dependencies, Bundler will yell at them and say, hey, you can't do this. And it really forces us into building these individual components and then building layers on top of that. I would say, though, to your question of how we actually got started, when we first started doing this, we had maybe 10,000 lines of application code. So sizable, but still not huge, fairly small. And the first extractions we made were in separating our API and admin dashboard and just putting it on top of a domain engine. And we had those three engines where the domain engine did have pretty much the entirety of our business logic, but then we had some of that business logic exposed via an admin dashboard, some of it exposed via API endpoints. We then started pulling down gems in places where we recognized we had opportunities to extract some of that code to be entirely stateless and not rely on the database, which I'm sure you all can appreciate how beneficial that is in working on code, just have it completely separated from persistence altogether, have it be almost just entirely functional in terms of looking at the inputs and outputs of the functions defined in those gems. And then from there, we kind of moved back to the domain layer and looked for places that were very extractable. An example of one of those is the Telematics Engine that we have that stores data on people taking trips and performs all the data science on top of that, because we really felt that just architecturally, there was a good opportunity for all of that logic to live independent of the application of it. We thought we should be able to gather data on how people are driving, record those trips in our database, record the scores that we're calculating. We basically score our users and produce a score that kind of indicates how risky of a driver they are. We thought all of that logic should be able to work independently from the actual tie-in to insurance and quotes and policies and everything else. So we extracted this Telematics Engine. And I think even there were some examples that kind of forced us to figure out a few things in our architecture. One of them being using PubSub or observer pattern to bubble events up from one part of the application to another one. I think this is something that you don't do if you're writing code procedurally in kind of a very natural way. So the way our application used to work, and hopefully I can convey enough of the business domain for people to follow along with this, but we would calculate a driving score for somebody every single night. And then part of that score also indicates if the user is eligible for a quote, which effectively for us means, do we have enough driving data to have a representative sample of how well this person drives and send them a quote for insurance? And that code for that used to really just look like, if eligible, generate a quote. That kind of meant, though, that our trip scoring function needed to be aware that a quote needed to be generated when a user becomes eligible. The hard thing was, as I just described, we didn't want our scoring code to even know that those scores were being used in quotes. We wanted to decouple those parts of the application. So what we ended up doing is building a PubSub interface where when a user becomes eligible based on their driving, we publish an event just saying, hey, this user is eligible now. And then that code itself has no idea what's hooking into that event, what other pieces of the application exist, how they use it. It's completely agnostic of all of that. And then our quoting engine could subscribe to that event and say, oh, when a user becomes eligible, I'm going to generate a quote for this user. And I think, interestingly, as you look at many components of your architecture, you do have a choice between which direction you want those dependencies to run. And we didn't really have those ironed out very cleanly before we introduced modular monolith ideas into the code base. But once we started doing that, I feel like we ironed out a lot of those.
Yeah, and it sounds like one of the main things that allowed you guys to make that transition easier is to have a concept of single responsibility, that within your controllers and models, you didn't have it just polluted with everything referencing one another, but you kind of started off from the ground right with having things segregated into their own areas to where it could be extracted more easily.
Yeah, that's huge. And obviously the single responsibility principle is a really good ideal for people to follow when building software. I think one thing that helped with that quite a bit is the fact that we really separated a lot of our functions that contain our business logic from the actual underlying data. And I think what you see in a lot of applications is all the data pertaining to trips in the trip class, which makes sense from an object-oriented programming perspective. It's really what you're told to do. Like if something needs to operate on a trip, instead of asking the trip for some data, tell the trip to do something. The trip can operate based on the data it contains and do whatever you tell it to do. And what I've really found is that the number of independent functions that we have that rely on a single source of data, especially for models that are core to a certain business domain, like for us, trips or insurance policies, end up with a ton of logic in there for disparate functions that really shouldn't go together. So a big way that we've really kind of implemented that single responsibility principle is by separating those functions that operate on data from the data itself and exposing the data more broadly and saying, okay, if we have 20 different things that need to operate on trips, let's define those things by the area of the business domain, by the concept, by the responsibility of that thing, instead of defining it by the data it's operating on and putting all of that in like a trip class. So actually, if you look at our active record layer, our models are actually pretty thin. And instead, we group all of that logic into service classes grouped by really kind of business concept or responsibility.
Cool. And another thing I love about the modular monolith or any kind of principle of single responsibility is that you reduce the number of merge conflicts you have when working with the team significantly, unless if two people are working on the exact same area. But I find that, if you had a really fat model, chances are someone else is going to be working in there, conflicting, and it just makes, merging in and doing that kind of stuff a much larger problem. So I definitely found in my development days doing the more separation, creating smaller files, more service objects and stuff like that, make it a lot easier to maintain the code.
I've definitely found that to be true as well. We have our teams at Root really organized around different parts of the business. And interestingly, I think the team structure and the parts of the business are organized around actually work pretty well with this architecture. And because we have entire engines and gems that are the primary responsibility of certain teams, then we do have some places that are really central to the business and multiple teams might work within one area. So we're not super territorial about who's making changes where. But especially for onboarding new engineers, which is something that becomes really important for startups that are growing quickly, it's incredibly helpful to have that engineer be able to open up the project and say, look at these 4 engines. These are the engines where our team is spending most of our time right now. Start to build up an understanding here, and don't worry about the other 35 engines right off the bat. Eventually, maybe make your way through them. But that ability to focus and onboard in a more isolated part of the domain is really helpful. And in some code bases where that is all together, like as one big monolith, I think that can be challenging to kind of sift through all that and figure out which pieces are applicable to the area of the business you're working on and which pieces aren't.
Yeah, absolutely. So when you guys go to run your feature test, so you're about to do a deployment, you run through the full set of features, but let's say if you guys are just working in a certain area that's going to get deployed, can you talk about how your testing works and what you guys are doing with that?
I think testing is one of the biggest advantages of this approach. One thing, we talked about this just a few minutes ago in the show, but one of the issues that teams have with a monolith is the test suite gets slower and slower the more the application grows. Yeah. And eventually you get to where an engineer can't even run the entire test suite on the machine. You have to offload that to CI. That's sort of the state we're in too. But one really big advantage of this approach is that we leverage the dependency graph of the application to selectively run tests for the portion of the code that you changed. And I think actually the best way to illustrate this example is to talk about Rails itself. Like when you make a change to a Rails application, you don't run the test suite for Rails to make sure you didn't break Rails. Like it's impossible when implementing a feature in your app to break Rails because your app depends on Rails, but Rails doesn't depend on your app. And we apply the same thing within our project. When we actually run our CI builds, we look at the git diff from where you branched from to determine which files you changed. Then we just run for the engines and gems where you made changes and any engines and gems that are upstream from those, like any engines or gems that depend on the engines or gems that you changed. And we don't run the test suite at all for the other engines and gems. And as you could imagine, there's a fairly high number of changes that you make that are just in one portion of the application. And we have entire swaths of the app that we know cannot be affected by those changes, so we don't run the test suite. We are conservative in our release process. And when we run the test suite for our release branch, we go ahead and run everything just to make sure we didn't get that wrong. But we haven't had any issues with this at all. And it's cut down on the time we need to spend waiting for builds significantly.
The way you do that, do you just map that manually, or do you just have logic that says, oh, I see this dependency is tied to that diff? Or how, that sounds hard is what I'm saying. It's magical from the outside in. Like, do you just create maps of how that could affect things, or what does that look like for you?
Yeah, that's you have it exactly right. We leverage Bundler and Ruby gems to understand the dependency graph for our application because all of those dependencies need to be declared. For an engine to use code from another engine, it needs to specify that dependency. And Ruby gems keeps all that metadata. So the awesome thing is when we go to run the build, we already have the graph of what our dependencies look like. We can then shell out, run a git diff command to figure out which files were changed. Then we look at that dependency graph. We say, okay, we need to run the tests for these engines, and we also need to run the tests for these because these could be affected too, since they have dependencies here. And then that's it. And the awesome thing, I think, is because our project is organized by domain, like most Rails apps are organized by layer of the architecture. You have controllers, you have models. A lot of Ruby developers are going to make a services folder. You have views. We don't have that. We have that within the engines, but not at the top level. At the top level, we just have areas of our business domain. We have quotes. We have policies. We have policy exports. We have underwriting. We have a lot of engines. But the nice thing is we see that in our build output. We use build kite, and when you look at the result of a build, you actually see red or green by area of the architecture. So instead of just, okay, you ran 15,000 tests and 37 of them failed, it's like, oh, it looks like your change in the quoting engine could have affected policies too. And I think that insight is really helpful for an engineer trying to actually track down what was broken by their changes.
This episode is sponsored by DigitalOcean. DigitalOcean is the hosting provider I use for devchat.tv. I also use it for my applications that manage the RSS feeds, scheduling, and sponsorships involved in delivering these shows. DigitalOcean is easy to use, has data centers all over the world, and provides terrific services including server hosting and object storage for delivering your web applications and assets quickly and easily. I use DigitalOcean because I love their interface. I get SSD storage for my servers, and their support replies quickly. So go check them out at digitalocean.com.
That seems to also underline, I'm imagining what it would feel like to be an engineer on your team. And I think it would feel like the structure of the code creates a structure, would create a structure in the brain of your developers. That you would start to see kind of this cause and effect between engines and business output. And like things would organize more cleanly. And so to be able to say, oh yeah, my code's affected, the ability to say, yeah, okay, so there's some dependencies here, or there's some logic here. So I could come in new to your team, and the architecture of the code seems to build an inside out learning approach as well. Like, okay, yeah, so functions of the business are more easily understandable because the way it's tested, the way it's architected, the way if I make a change here, it affects things over there. Now I get it.
Yeah, definitely. And that's, especially as we're onboarding the number of engineers that we are and trying to grow our team, we found that some of that clarity around how the application is architected is really helpful. We've actually used GraphViz to build a visualization of what that architecture looks like, which also just helps people get started. Like, okay, I can see that the code components here are used upstream here. I can see that they have dependencies here. I can see that this stuff is unrelated. Now, it still takes time to actually read the code and understand how it works. But certainly having some visibility into that is really helpful.
I think that at least I've always gotten stuck in knowledge acquisition, in my career, and I love learning things, but I've realized there's got to be a 10x boost when I start doing things first, and then I learn what I need to learn later. That the whole inside out towards learning, being able to see enough that I can get busy, and then I can fill it in with stepwise improvements in my understanding of how the system works. And that seems to be a humane way to live.
Sure.
It's really, really, I don't know why it took me so long to realize, but I read, Richard Feynman will talk about that. He'll talk about you learn a thing and then you teach it to somebody and you notice what they didn't learn and then you figure out how to teach it more simply. But it's that inside out perspective of is there a practical use of this? Can I actually talk to somebody and connect? Can I actually work on something and have it do what I intended it to do? It's huge.
And the thing that's really fluid for us is the fact that it's just all in one repo. I think we've really gotten a lot of the advantages that you have with a monolith. And I think monoliths do have advantages. I know the way most engineers talk these days, you wouldn't think so, but there are some advantages just having one project in one repo and one code base. And we have a lot of those advantages. You're not cloning 15 different Git repos to try to walk through what that looks like. It's all there in one repository in one project. At the same time, I think we have a lot of the advantages that microservices have in terms of having boundaries, having some isolation, having versions of the code, proportions. And it's worked out very well for us.
Plus, often when I see people break up monoliths, it's often because the new developers can't understand the monolith. So they can't understand it. They break it. We slow down. And finally, somebody says, okay, we've got to break this up. But if you've architected this way where you can have separation of concerns, where you can have an understandable flow, then you get what sounds like the best. I imagine you have quite a large code base. I imagine this is not a trivial app. And to be able to handle something this complicated this well and have new people come on board and people aren't screaming with pitchforks and torches, we have to break up the monolith. That's a huge win. Because that's when every time I've broken the monolith, it's because we can't. We've reached our limits to growth. We can't get new people on, and we can't add new features successfully. We just the inertia of the project just is too complicated, and so we have to break the monolith up at that point. But this kind of structure that you're giving it sounds like it's working very well.
It is, and you're exactly right that like different portions of your application have different criticality. So one nice thing too is we can pay a lot more of attention to a pull request that modifies our rating engine than we do for a pull request that modifies, some feature that, yes, of course, we want to take the reliability of that software seriously, but it's not going to have the same sort of business impact as a breaking change in our rating engine would have. And that's pretty helpful too. Our application has grown quite large at this point. I think we have about 70,000 lines of application code, just pure Ruby code. But we have our app. Today, I just checked. I switched over my terminal real quick to look. And that logic is spread across 48 engines and 25 gems.
Wow.
Engine for each state. No.
No, not quite. We did figure out like a pretty good approach to basically making states almost just configuration, where we don't have lines of code in our code base that say if Ohio. We do have lines that say, if this feature is on or this state is parameterized this way, execute this behavior. But I think we've kept it fairly agnostic from the states themselves, and it's been a good approach for us.
Wow. When we were getting ready for this podcast today, we started talking. I'm an old dinosaur, and I built an insurance company from the ground up way long time ago. And I'm jealous because I know the kind of complexity you're up against. And I'm also know about the kind of flexibility you've been able to do. So we had the same problem where our monolith got out of control, but we also had a hard time with parameterizing state and being able to grow the complexity. We would get we'd open up into new states or new lines of business and couldn't grow the way we'd architected several decades ago, our app. So it sounds very like it's well done. So having been in those particular trenches, knowing how hard the problem is, this is why I'm excited. This is why I wanted to sit back and just listen to how you did this, because wish I'd known then what you know now.
Yeah, thanks. You were working on that insurance company quite a while ago. We do admittedly have a huge advantage just being an insurance carrier that's built on top of modern technology. And starting Root in 2015 with the technologies and services that are available in 2015 is a huge advantage for us. And that's honestly really the only reason that we can even compete with the behemoths in this space. You look at the companies that we're competing against, they've been around for a century. They have billions of dollars, probably tens of billions, maybe even hundreds of billions of dollars in capital. And we're a brand new company with a really small team that in many ways is going head to head. We're selling the same product that they are. It's ultimately car insurance. We have a very different approach for it. I think that approach has been insanely well received. If you look at our application now on iOS, we have a 4.8 star rating with over 5,000 reviews. And this is for an insurance app. It's been tremendous. I'd say one of the most satisfying things about building Root has just been seeing what our customers have said about how happy they are with the product, what it's meant to them. Car insurance is expensive. For a lot of people, it's a very major expenditure. And a lot of people are just paying way more than they should be based on their actual driving behavior. You look at our app on Android, and we're now a top 50 app in the finance category, ranked ahead last time I checked of Allstate and USAA. I'm still a bit behind Progressive and Geico, but we're getting there. And especially when you consider the fact that we're still only live in 17 states, it can reach maybe about 40% of the population of the United States. We still have a lot to come.
That's really exciting.
You guys need to get some Geico commercials or Geico-like commercials. I love them.
Still, the role is still open. We have yet to identify our talking animal that we're going to use to promote our insurance company.
I nominate Catherine as the voice of that talking animal.
It'll be a sung animal.
There we go. Singing sock puppet. We've got it for you.
Marketing for insurance companies is outrageous. Geico alone spends over $1 billion a year on marketing, and you can hardly watch anything on TV and not see at least 3 or 4 car insurance commercials, which you really notice after you start a car insurance company especially. It's like how you buy a new car and you notice everybody driving the same make and model of car as you. So we look at that a lot. Interestingly, we don't do a lot of national advertising at this point because we are only live in 17 states. So we mostly leverage marketing channels where we can reach people based on geography. But as we get closer to being a national insurance carrier, and we hope to be pretty close to that point by the end of next year, who knows? Maybe one day we'll run a commercial. Probably no talking animals, but if so.
If so, we know who the talent is.
Right.
You heard it here first.
Deviating so much from the normal Rails architecture, were there any gotchas in configuring that to work for your engines folder, or was it super easy, just change a few line of config?
There were a few gotchas. I'm trying to think what they were. We did this quite a while ago. Definitely the way that test suites for engines are set up, I remember being a little bit awkward for us because you still need to boot them up to run the test for them, like within a Rails application. We figured out a way to get that to work. I also remember Spring and trying to cache the Rails process was a little bit complicated because Rails kind of has that idea where the base app that code is loaded up, it's in memory, and every time you go to run a command, it just forks off of it, so that command runs much faster. And I think we ran into a few snags with that too. We also had to do a little bit of work. What we ended up doing was adding a couple of hooks in our gem file that if you're in a certain engine directory, like engines/policies, and you run a command, we see that you're in that policies directory, and then we make sure that we only load up the policies engine to make sure that you're not using code from outside of there. And getting a couple of those things in place took a little bit of work. So ultimately a few snags, but I wouldn't say any ongoing pain. I would actually say the majority of our engineering team works on this Rails app just like they would any other. And anything that they trip over is probably a good thing that they ran into. Like, oh, I tried to use code from this engine over here and that dependency isn't declared. And that kind of forces you into realizing that and making a decision about, oh, is this actually the right architecture for this feature? Should this code be over here, accessing that code over there, or should this actually live somewhere else?
Yeah, when I was messing around with engines quite a bit, the one thing I found really annoying was the mail previewer didn't really play nicely in engines. This was back in the Rails 4 days, so I haven't checked it out to see if that issue's kind of fixed. But when testing out your main application and going into the Action Mail previewer, you couldn't actually look at the emails that would be generated for engines. So have you guys had to deal with any of that, or do you not really have the emails within the engines?
We don't actually. Although I do think one of our engineers did something with the mail preview functionality. It's a pretty cool feature of Rails a while ago, but we ended up offloading that to a third-party service. We use Braze. It's another good example of where the architecture has been helpful. We actually right now have most of the integration with Braze sitting at the very top of our dependency graph. So instead of individual components of the business logic needing to know that, oh, I need to send a notification here and here are all the different parameters, we put that at the top of our dependency graph. And we've debated whether or not that's the right spot for it off and on, but I think right now that it is. And the awesome thing about it is we use that pub sub architecture there to send out events when we need to. So when somebody buys an insurance policy, there's a pub sub event that gets published saying somebody just bought an insurance policy. And the core domain logic, like the policy logic itself, really has no idea what sort of email needs to go out or anything. And then our notifications engine subscribes to that event. They're like, oh, somebody just bought a policy. Let me send them an email. The nice thing is by putting that hook at the top of the architecture, at the top of the dependency graph, we can actually pull in a lot of disparate data elements because as you could imagine for our marketing team, they might want to leverage that policy purchase to maybe promote something else. Like, oh, hey, thanks for purchasing a policy. We see that you've referred one friend from our paid referral program, refer two more, and maybe you'll get this benefit. And some of that we can really kind of only do by tying all of these different concepts together. The nice thing, we just pulled that up to the top instead of kind of coupling a lot of different pieces of the business logic by needing to check to see the status of your paid referrals anytime somebody purchases a policy, for example.
That's all fascinating. I love it. Is there anything else that you want to discuss? Anyone else have questions?
I do think there's one more thing that I mentioned. One other strategy that we've taken is with our exception reporting. I think that's another area where sometimes microservices feel really beneficial because you end up with exceptions coming from different parts of the application. All times those are all funneled into one place. You have a bigger engineering team. We now have about 35 engineers at Root, and people need to look through those to try to sort out what's happening. We've actually separated a lot of that out as well, even though we still have a single project. We wrote really just a little bit of code that dispatches exceptions from different portions of the application into different projects. We use Airbreak for our exception and error monitoring. So we have different queues for different teams, and basically different areas of the application will report exceptions into different projects in Airbreak. So the nice thing there is, even though the application has grown larger, we have more errors that pop up. Hopefully not too many. I think we've done a pretty good job with quality and reliability overall, but we certainly have some. But by having those go to different teams, we can have teams have individual triage rotations then for being responsible for the reliability of those exceptions. I think that kind of thing is just another technique where you don't have to go from one extreme to the other. You don't have to go from having one project that has everything all together to pulling out separate services with different error reporting and monitoring and exception reporting. You can still just have that one modular monolith, but still have your exception reporting segmented out by team or area of the project.
That's really cool. Especially being able to triage it or send it to the subject matter experts of that particular area of the code, instead of having just one new person on call. It's pretty cool.
Yeah, definitely.
All right, Dan. Well, if people want to get a hold of you or see some of your other works, where can they look you up?
They should definitely check out what we're doing at Root. You can go to root.engineering and read more about our team and the way we work and what we're building here. You can also go to my personal website. It's Dan-Manges, manges.com.
Awesome. Well, thank you for being on the show today, and we'll move over to some picks.
Yeah, thanks for having me. This was great.
Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
All right, Catherine, you want to kick us off with picks?
Sure. So my pick this week, I was listening to a podcast called Breaking Into Startups. That is a podcast around how to get into the tech world with a non-traditional background, which is me. And I was listening to a great one about how broken the hiring process is when it comes to start getting people from non-traditional backgrounds. It was a interview with Aileen Lerner, who is the CEO of interviewing.io. And it was so interesting. And it talks about how, hey, you could be missing out on some amazing candidates just because they're being filtered out at the first step because they don't have a CS degree or they're not from this school or whatnot. And how how that's broken and how it could be fixed. It's really interesting.
Cool. All right. And then David?
Yeah, I'd like to plus one that. I've been surprised lately on Quora and on Medium how the hiring process for software is a lot. It's surprising to me how hot that is right now, especially for non-traditional people. That we can actually see what's going on. I wrote a few comments here and there, and it was really fascinating how important that is right now. So pay attention to how you're hiring. So I'll pick a plus one to pay attention to how you're hiring. The other one is a book. I'm just absolutely fascinated. I just picked it up the other day, and I'm almost through with the whole book. It's that good. It's called Atlas of the Lost World: Travels in American Ice Age, something close to that. It's this great book where this explorer, he's a scientist and archaeologist, and he goes out there and he gets up on the ice sheet. And he goes and he eats snails. He's around in Peru and Alaska and California and Washington and Canada, and he's talking about inside out how migration in the Americas might have worked. And the thing I find fascinating about it is the insights that he gets by going there, by learning. It sounds a lot like our conversation we had today. By building a system, by going there, by engaging with real people in a real way, by hiring people in a real way, that's where value is found. Being authentic with our experience. So this is a great read. You'll love it if you pick it up. This guy's really done a wonderful job reinstilling in me a sense of adventure and curiosity.
Cool. And I'll jump in there with a quick pick. It's a show on Netflix. I like dry British humor, and this show is The IT Crowd. It's really funny if you haven't seen it. So if you haven't, get a Netflix subscription and check it out. It's pretty horribly dry humor. So, all right. And Dan.
So for my pick, I wanted to mention Postico. It's a SQL client for OS X. Root is an extremely data-driven company, even way more data-driven than other companies I've heard talk about being data-driven. We use Redshift for our data warehouse, and I spend a decent amount of my time in Postico doing analysis around the data that we have, and it's like a very great, simple client. I probably spend about as much time in it as I do in Vim these days.
Awesome. Well, thanks again for being on the show. And I'm excited to see Root come to my area so I can see how cheap or expensive it will be.
Yeah, we're working on it. If you're a responsible driver and safer than drivers on average, you can save quite a bit of money on your car insurance.
I've not gotten a speeding ticket in over 10 years, surprisingly.
Nice. I don't think I have either. Nope, that's not true.
I've been a great driver. I don't want to talk about my 18-year-old son and his 3 accidents. I'm not going to mention that. total 2 cars.
Oh dear.
Yeah, moped for him.
How about a bicycle?
I accidentally totaled 2 cars in the same weekend. Neither were my fault. It was actually up in Columbus, Ohio. It was a crazy weekend.
Man.
That was 20 some odd years ago, thankfully. All right. Well, then, thanks again, and we'll see you online.
Thanks, guys.
Thank you. Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.